Hi, Professor. Hope all is well. This is my presentation on cool stars and spectral classification. Hope you enjoy. So, to start off with, when a star is born, they are born with a specific mass. And this mass determines their brightness, their temperature, their expected lifespan, and type of death and spectra. So stars are classified according to their spectra. And a star's full classification includes spectral type, which is their line identities, and their luminosity class, which is their absolute brightness or absolute magnitude of the star. So, spectral classification, spectral lines are caused by different elements present in a star, such as hydrogen. Um, the spectrum also relates to their surface temperature. And astronomers classify stars based on the relative strengths of their absorption lines. And the surface temperature of the star is also associated with the specific spectral classification. And there's 7 types of spectral classification, which are O, B, A, F, G, K, and M. Coming from O, stars decrease in temperature. From O to M, stars decrease in temperature, and they become less massive, or in other words, smaller. And a common way students and astronomers remember the proper order of the stellar classification from the hottest blue stars to the coldest red stars is a memory device, which is OBA, fine guy or girl, kiss me. So that's kind of how they remember the order of the 7 main types of spectral classification. So here is a display of the HR diagram, the Hertzsprung-Russell diagram, which displays the temperature and luminosity of the stars based on their spectral class. So as you can see blue in the top left and red in the bottom right. And the stars actually form a diagonal line from top left to bottom right. And that is them like decreasing in temperature. So starting from the top left, the hottest stars are displayed with the highest luminosity. And as you go down, they decrease in temperature and they also decrease in luminosity. So there's also stars around those diagonal lines, or below and above those, that are kind of scattered. And so not all stars fall on the main sequence. Stars below the main sequence are called white dwarfs, and those above it are called giants. And since hotter stars are blue and cooler stars are red, a white dwarf is hotter than a red giant. So here's a picture of kind of this characteristics of the spectral classes from O to M. Again, you can see the colors. From O, it has the bluest color, and M has the reddest color. And you can see their temperature start off from blue is 41,000 Kelvin, and to red is about 3,850 Kelvin. You can see this the temperature decrease and also the color go from blue to red. And you can also see the absorption lines. And you can see how certain elements become less noticeable in the stars, like for instance, hydrogen is one of them. So measuring temperature of the stars. So astronomers classify stars based on their relative strengths of their absorption lines. And the lines in a star spectrum correspond to a spectral type, that is their temperature. And as you can see, the hydrogen lines are weak in cool stars, and they increase in strength as the temperature increases. And when they reach to the A stars, then they weaken at higher temperatures. This is a example of Morgan Keenan spectral classification, another way to see um, kind of how the temperature decreases as you go from O to M. Just another idea. So here we are talking about the main characteristics of each classification. And you told me you would like me to talk about F, G, K, and M stars. So F, G, K, and M stars are the more cool stars. So we'll start talking about that. So for class F stars, they are still quite powerful, even though they're not the hottest stars. They are still pretty hot. Their spectra is characterized by weaker hydrogen lines and ionized metals, and their color is white with a little bit of yellow. So their temperature is around 6,000 to 75,000 Kelvin. Their size is 1.2 to 1.6 times bigger than the sun. And they have weak hydrogen lines, strong calcium, and other ionized metals. Class G stars are well known for the reason that they are our sun. Our sun is of this class, so that is a way that people remember. Um, they have even weaker hydrogen lines than class F stars and neutral helium lines, but along with their ionized metals, they also have neutral metals. So their color is yellow. Their temperature is around 5,000 to 6,000 Kelvin. The size is about 0.8 to 1.1 times the mass of the sun. And they have weak hydrogen lines, neutral and ionized metals. For class K stars, they are orange, which are slightly cooler than our sun. So some K stars are giants and supergiant. An example is Arcturus, while others like Alpha Centauri b are smaller. They are extremely weak hydrogen lines. Sometimes they're not present at all, but mostly they have neutral metals. Again, their color is orange. Their temperature is 3,500 to 5,000 Kelvin. They are smaller and cooler than our sun, and they have faint hydrogen lines and strong neutral metallic lines. So as you can see, the hydrogen lines start to fade away as the stars get cooler and cooler. And last but not least, class M stars. They are the most common class by the number of stars. All red dwarfs are class M stars. For example, Proxima Centauri, which is the closest star to our solar system. The spectrum of an M star shows lines belonging to molecules and neutral metals, but hydrogen is usually absent. At this point, hydrogen is completely not shown with class M stars. The color is red, which means the coldest, and their temperature around 2,500 to 3,500 Kelvin. They range from 0.5 to 25 times the mass of the sun, and they have strong metallic lines and wide titanium oxide bands. And here are my sources. Thank you very much. Bye.